review the project. I try to update the project in the e-learning as soon as possible by today, and maybe in next class we're going to discuss what about the project, what you need to do with your team member, and when you need to submit, because the submission will be before final exam for the project. Okay, last time we did take a look into addressing mode. Relative address, there is a lot of addressing, registered addresses, how you're going to apply. I forgot already which we end our class. So we're going to do some recap. Okay, in the addresses, we have several, 6 altogether. Addressing mode: immediate, direct, indirect, register, indirect, and lastly the displacement. So you can see that this is example of immediate addresses. We did take a look, and also the example last time, how you're going to apply the indirect addressing, especially in terms of the symbol. So the symbol, how you're going to apply, if direct or indirect. Last time we discussed together already, okay? Alhamdulillah. So this one is indirect addressing. You can see the example also. And I already also mentioned about the answer. Sometimes you're not going to get a similar answer for the black color one, because the register for each computer is different. For indirect address, so for indirect address here, there is also example we already discussed. We done the example, and I think, if not mistaken, I already copied this code and I tried to run in the Visual Studio with all of you. And we look the answer. I hope you can also try to do it in terms of the exercise also. For the register addressing, okay, you have advantages and disadvantages. I think this one is not covered yet, so might be I can try to explain here. So let's take a look in terms of example 7. If I already discussed, it's okay. It's just a recap. So under register addressing, this is an example of the code. You're going to use register, means at this part, you can see. So you use a register as the address. Let's say here EBX as the addresses. So you're going to point EBX and put into the EBX, add, and so on. So this one is the addressing under register. So let's take a look. Move EAX 0 means it is going to be put immediate value to the EAX. So this is the addressing. So please make sure also remember about the size. Last time, if in a different size, you can see in the example, the addressing, the size for the register also will be different. BL, if you still remember, at bits. CX is 16 bits. So you can see the size also, okay? So please make sure carefully look also in terms of the size. So here, next one, we have direct immediate also, the value, immediate value. We have 2000H. So we're going to put directly to EBX. But please make sure remember also about the size. Immediate value from this 3000H, move and put it to the ECX. And then we have the register addresses. We look back at the EBX as a source. So look at the value of EBX. And this value will be directly putting to the EAX. Luckily, it is a similar size. So here, later on, you have add. So you're going to add plus the value. Now we have ECX. Look at the ECX value and put at the EAX, adding. So this is the final answer. So try to also copy, run it, and maybe you can also try to do each line, single line. You can see the answer, what will be effect to your register. Okay, register indirect addressing. So you can see what is the advantage and the disadvantages. Let's see directly in terms of the example. Okay, for this example, I remember now, we already done this one. We already discussed this example. You can see you have the data, which is array 1 and array 2. You can draw your step by your own to put all the value inside. Please make sure you see the size also. And let's see one by one in the code. So for the code here, you have offset array 1. So this offset size, address of offset array 1 starting here. Let's say for the first one, it start here. And again, in the question, it will inform you the initial address. So that's why directly sometimes it's not going to give direct 1, because initial is will provide the value. So instead, like maybe it's 2. So you need to calculate until like here. Okay, address 1. In question, it will inform. So it is a 00404004. We start at this offset. So this offset value is a register indirect addressing. So you're going to sorry, this one is not offset directly. This one is address of data that store in a register. Okay, now second line. We have move EDI offset array 2. So for array 2, we have here, after you already put all the value in your stack. So we have like 04, 05, 06, 07, and it start at 08. So at 08 here, this will be the offset of array 2 starting. So this value will be putting at EDI. And third one, BL EDI. So it is indirect addressing. So let's take a look into the size. So it is a 8-bit. So for 8-bit, you look at the ESI. So this is ESI value. Please make sure you tag from the right, not from the left. So you're not going to tag like this. This is 8-bit, right? Not going to tag this one. But instead, you're going to ESI. Why is 10? ESI value direct. Oh, okay, sorry. This one you're going to see. This is the ESI address. I forgot already, see? So you look into the addressing here. The value. So this value you put inside here. And you're going to look at the offset. So at 04. At 04 here, it is the value of 1H. 1H is not 10 decimal. It is 10 hexadecimal. After that, similar also, you look into the offset value of EDI. Look at the point here, 08, because this is the value. So here it will be 23. After that, 01. Because CX is 16-bit. Although this one is the point for your EDI offset, but you need to have two, which is 1 byte. So 01 and 23 for the CX. Then you need to move to the next. Move EDX, which is the value. This one is direct. So you still remember, right? Which one is indirect, which one is direct. So if direct, the value inside directly put to your register. This one, which is indirect, means you see at this point, you go and take a look into what is the data inside. That is the difference. Now you can see the difference between direct and indirect. We have another one. Move AL. This one is indirect. If indirect, you can see EDI 0040 4004. And then you have the value here. Plus 1. Just now I draw you. We start at 04, 05, 06, and etc. Right? So now we have plus 1. Indirect. Mean indirect, you're going to look into the data inside this value. If direct, it directly put the value. Indirect, you need to look into the stack. So indirect here, plus 1 means 05. What is the value in 05? It is 1, 1. So you're going to put 1, 1 in the AL. So this one is not too hard. You can try to copy and step over to look into the answer. Might be also you can, last time I mentioned to you, might be you can add some more. 14, 16, whatever numbers, and then you add your own array 2A, let's say. And then you put D word. So just take a look what is the difference. Okay, you play around with the code. Okay, this one is basically the explanation from this example. So let's take a look. You have another example 9. Just now example 8, which is similar, only you have a different code still under register indirect addressing. And indirect, okay? Indirect addressing. About the data here, I don't know whether it is used a similar one, but you were given with the data and the offset directly already. So move EBX 404000H. So this one is direct value. You just put into your EBX. Directly put the value inside. And then we have here indirect addressing. So register indirect addressing, you have the value of EBX. Look into the stack. What is the value? This one, luckily, it is DL, which is at bit. If it is a EDL, sorry, there is no EDL. Let's say it is a CX. So CX, what you're going to put, the value is 2455 because it is 16-bit. Okay, this one for the second line. And then you have increase. Increase means you're going to increase or add 1. Increase 1 time. Okay. EBX now is 00000 value. And you increase or plus with 1. So you have this one. This value after you increase. So after that, you can see you have again the register indirect addressing. The value inside, you look into the stack inside. So you have the CL. CL again, it is 8 bits. So you just take this value, 55. If you do frequently exercise, it's easier for you. And what else? Normally for test 2, it will always a question from the example and exercise. But before I forgot about your test. About your test. This one is final. Okay, about your test 2. Your test 2 will be... I off mic. Okay. Your test 2 will be at 28 May, 2 p.m. until 3:30 p.m. 28 May, 2 p.m. until 3:30 p.m. But the duration might be if there is any changes, I will inform you later. But just for you, soft reminder, because for MJIT student, they have, I think, what ceremony? I don't know, graduation or what. So if you cannot attend the test 2, please inform me as soon as possible so I can rearrange you to join MJIT student who cannot take 28 May So you can join them to take a year, I guess, a year from this date. Okay, so under your test 2, it will be cover chapter 3 and chapter 4 only. Only 2 chapter. Although it is 2 chapter, I think most of it's going to come out from the code program. And there is a part A and part B. I don't know whether this time it will be continuous last time, like you need to answer in the e-learning embedded type of question, especially for part B. I guess all start from chapter 3. You have a question for your part B. For test 1, no, right? Only module 2. But for test 2, you have both chapter 3 and chapter 4 will be covered for part A and part B. How many questions? 25 for part A. And part B, total mark is 30. About 6 question. 6 question, yeah. But later on, after confirm all together, I will re-inform you, and we're going to do more and also recap together like what we did in our module 1 test 1. Okay, that is about test 2. Just inform me because I remember now. Similar also in your project, I need to give you the project. You're not going to get similar question for all the section. Okay, you get similar question for section 1 and section 5. But another section get a different set of question. So I will try to upload as soon as possible about your project. Let we continue with our module 4. So inform me, okay, as soon as possible if you cannot take the test 2 on 28. But of course with a valid reason. Let's we move on the displacement addressing. Displacement addressing, it is a very powerful mode addressing which is combine the capability of the direct addressing and register indirect addressing. So this one can be also asked in your MCQ, which is what a combinations for displacement addressing. So you can see between direct addressing and register indirect addressing. Might be we just change it. We put direct addressing and indirect addressing. So you need to know whether it's true or not. So address field has 2 values, which is A as a base value and R as a register that hold displacement or vice versa. So this one as a theory only, you need to know in terms of the example. So the relationship, relative addressing under displacement addressing, you have 3: relative addressing, base register addressing, and index addressing. So now we look into the first one, relative addressing. So under relative addressing, also called PC relative addressing. This is another name for relative addressing. Sometimes in question, we did not mention about relative addressing, but instead we directly put the PC relative addressing. The implicit reference register is the program counter, which is your PC. So your R, if you still remember, R is a register that holds displacement. So R equal to the program counter. This equation you need to remember because sometimes you were given the value of program counter and also your A as a best value. So you need to find out the value of EA. The next instruction address shown in PC is added to the address field to produce your EA. So let's take a look how you can see the relative addressing. So displacement addressing here under relative addressing, this is example of your code. So your PC, you're going to have a counter every time when you are having a loop. So where is your counter? Of course, your ECX. Normally your counter, you cannot start at 0. Last time I mentioned you, right? Because if you have 0, you cannot even loop. So you directly go to exit. So there is a correction last time. I think we already covered this slide also. So here, this one is a similar things. You know already how to inform and move all the register with the direct value. So under our loop area here, we start with the offset of 0, 0, 0, 0 to 8. So when we have the conditions of loop 1, L1, so we will play around and looping until our counter is finished, reach to 0. So we will directly go to the exit and do this code, which is push plus 0000H. So from here, we're going to jump to this address if we already end. So if the PC pointer at 39, which is the end of the coding or program, so it's mentioned from here when you are having a loop, which is you need to go to directly back to the 28 unless after you finish or pointer will be point to the 3739. So how to measure your destination size? So you need to know the target, where you're going to target, which is loop. You're going to go to L1. So L1 is your target. So where is your source? And also destination. Destination is supposedly at the last one. So here, the equation is destination equal to target minus source. Okay, here you can see your L1 is at 2.8 and your PC of the end of the code is 39. So your destination value will be equal to minus 11, which is it loop back, which is reverse. If you have positive, means that you go directly to the end. So if you go before that, it's going to be reverse. So for this value, it is under your machine's value. Similar also all of this. but actually we're going to reverse at 11 time or offset. So you can see here negative because it's jumping backward. So that is under displacement addressing, under your relative addressing. So second one is best registered addressing. Similar also, you're going to have EA equal to A plus R. So A hold the displacement, R hold pointer to best address, and R also may be explicit or implicit. Example here, example 11 here is under displacement addressing. You were given with your data, you have count array 1, array 2, array 3, and also your code, which is your coding under displacement addressing, which is best register addressing. So here is your best index addressing. Let's see one by one. When we have the value, we're going to put into our offset, our stack. So please make sure you know how to calculate your offset, of course, how you're going to put inside. Okay. So I still remember also this example we already discussed together. You can see under move ESI, you have the offset array 1. And again, in the question, it will normally inform the initial value of the offset. So we start at a similar value like a previous example. This one is direct. It's not too hard. And now we have the best index addressing for this line. So under this one, you're going to have word. So it's mentioned also the size. So you're going to have the pointer PBX plus ESI. So the value you need to add them together. Okay, after you already add them together, you need to know also about the size. Okay, it's mentioned word, so you know the size, and you're going to move it into the X. And you can see it is a displacement addressing, which is direct also. So you're going to see the value inside the stack. So you're going to have the value 8, 9, and 6, 7. So please make sure you try to put in the stack. And please remember that you're going to have 0, 1, 2, 3 until 9. In hexadecimal, it's not continue from 9 to 10. Okay, let me give you example. 40004. We start at the offset of this one. And then we continue 005, 006, 7, 8, 9, and we're not going to go to 1, 0. Why? Because this is hexadecimal value for this one. That's why we will go to in term of adding, okay, this one, in term of adding is going to go to A, B until F. After F, it's going to go 1, 0. So then you're going to get the similar value offset here and the value of 89767. Try to locate in the stack. Okay, that is the things under this pointer. So supposedly you're going to get this value, okay? Then we have, you're going to add the value of ESI and EBX. Directly adding is not a problem. And move again a similar one. You need to have the EBX. No need to add 1, 0. Sorry. So you have the words of PTR EBX. So EBX just now you have the value here. So you need to see the size. It's a 16-bit. So you have the similar answer for the previous one. Okay, and lastly, we have the indirect addressing. So here is the exercise. You can try to do it for the exercise and you place it all together. Let's see. Given the tree array, okay, similar one with the previous, I guess. See the value. Oh, this one is 4. Then you fill in the value. Where is it? Here. The offset of the memory. Assume that first offset. So you can see here, this is what I mentioned. Normally in question for test or final exam, we will provide you with the first offset value. Not like previous example that will not give you initial, right? But supposedly in test and final exam, the first offset value will be given. So you know, okay, start at the array 1 is going to start at 00404004. So you just fill in the value, the offset, and also the value for the start. The value of data store using this one is the similar thing. So means that for words, you're going to type this first and next. This first, second, third, and another one. And then continue. That is under Little Indian order. So try to do this exercise, which is totally similar with not similar with this. I guess only this part. And you have here the example under displacement addressing. You have index address. Is it similar? By word, the word. Might be the code is different. Okay, this one is just story, but now you have a code. So in this example, you can see your ECX is equal to 4. It's rarely you're going to get 0 because if 0, you cannot do a looping. So if 4, you can count 1, 1, and then you will reduce 2, 3 until you're going to get 0. Then you're going to loop to exit. So where is your best? Let's see here. Move EX. Firstly, your EX value is 0. Move EX, which is your counter, register counter, equal to 4. So under looping here, you have array 2 EAX. So your value of your EAX 0 here. So you start at the offset 0 and array 2. Move BX, so array 2 plus EAX. This is the mentions of the adding EAX here also. So BX, move array 2, and you're going to add the displacement because of the equation. So from here, although you can see it's basically similar to this code or this one. Then you have add EAX equal to 2. You're going to loop until your counter equal to 0. So first time, we're going to have EAX equal to 0. And then your counter ECX equal to 0004. So when you have here, just now you already look into that it is similar to array 2 plus your EAX. Your EAX is 0. So it start at this array 2. So array 2, where you start? Initial value also is not mentioned. Assume it to be I don't know how to assume. So here it's directly given 8. 1, 2, 3, 4, 5. I think similar one which is 4. 4, 5, 6, 7, 8. Yeah, it start at 404004. But we start at this initial value. Supposedly it's inform, okay? We start here 04, 05, 06, 07. Here will be 08 for our array 2. So we add this with 0000. Then we have the value here. And from here, we're going to put and move it to the BX. We're going to move it to BX. And remember, our BX here is 16 bits. So it will take 2, 3, and 0, 1. 2, 3, and 0, 1. So you have 0, 1, 2, 3 hexadecimal for BX. Then you're going to add your EX with 2. So here, just now your EX is 0000. So you add with 2. Now your update value for your AX. Later on when you loop, it will be 2 now. So that's why you're going to add here. Wait, okay, sorry. It's hard for me to directly continue talk, okay? Now you can see here, when you loop, it's mentioned when you loop to L1. So our counter just now is starting at 4. So when we loop, it's going to reduce 1. So now our value for the counter is ECX. Okay, it's going to continue looping. Now we have the value, means we're going to loop again. So we will continue doing a similar thing. Now we have the value decrease. So now we're going to have the value, which is second loop. We have the value of array 2. Similar the value, which is the offset. But The difference is our EAX value. Now our EAX value is already 2. It means we're going to add with 0, 2. So C back 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9. So we have another one is E. Tadi tambah 2, 1, 2. So you can see here, it is A. It is not, after 0 9 here, it is not directly go to 1, 0, 11, 1, 2, 1, 3. No, you need to have A, B, C, D, E, F. And then continue with here 10, 11, 12, 13, 15, 16. I think it's correct. E, F, 10, 11, 12, 13. So you can try to 14 here, 15, 16, 17. Okay, that's why just now I mentioned to you that after 0, 9, it's going to go to A. Now we have a second loop. For second loop, you can see here, this is similar. Array 2 is fixed. Array 2 is fixed. The things that different is our EAX. Our EAX now is 2. Because it's 2, so you're going to add them together. So after you add them together, what you will get? 8 times 2 hexadecimal. 8 times 2 is going to get A. It is not 10. Okay, hexadecimal. This one you learn in digital logic subject, hexadecimal numbering. Let's see. So our array 2 is 0, 0, 4, 0, 4, 0, 0, A. Kenapa dia hilang? So A here, you're going to see our A value is 3, 4, and our X is 16. We have 0, 2, 3, 4 for our BX now. Okay, now our BX will be 0, 2, 3, 4 hexadecimal. And again, for the next one, we're going to have 8 EAX 2. So from 2, we're going to add another 2. So our value of EAX now is 004. And you're going to call down register. So you're going to store it and to print it out. And you try to loop again. Again, you're going to decrease 1 time. Our ECX will be decreased. Because there is still value, so you're going to loop again. If it is reached 0, then you're going to exit. If you have a value, you're going to loop. So you try to do also this code in your Visual Studio. Do it one by one, and then you can see the movement. Okay, now. Kenapa tak boleh gerak? Okay. So now we have the decrease the value of ECX. The third loop. I dah tambah 2. Okay, dah tambah kan? It's already adding. So now, similar also, you do a similar step. Our EAX value now is already changed. And again, you can see 8 plus 4. Supposedly, in a decimal, we're going to add 8 plus 4 equal to 13. But hexadecimal value 13 is equal to C. That's why you get the address of 0040400C. So I forgot already what is here. So our C is 45 and 0, 3. 0, 3, 4, 5. So now our value is 0, 3, 4, 5 for our BX. And you're going to increase again. Your EX become 6. Become 6 now. You go to the loop 1 here. And 1. You're going to decrease again. You're going to get 1 for your counter. So still have the value or not? So you still have a value. That's why you're going to loop again to L1. Similar, you're going to continue, but now you're going to add with 6. So 6 add plus 6 is going to get 14. But 14, normally this one is in terms of decimal. But when you add hexadecimal, you're going to get the E. For E here, look back at the data at the top here. Then you're going to get, I forgot already, you're going to get 5604. Okay, 5604. And from here, you do adding the EAX with 2, you will get 8. But now you're going to see that your loop L1 will be getting the ECX 0. So after 0, you're going to directly go to the exit loop because the value is 0. That's why just now in the equation, previously I mentioned supposedly ECX cannot be 0 because if 0, you're going to go directly to exit. You cannot even loop. Okay, that's why there is an error for the examples previously. So it is how you're going to loop inside your looping. It depends on your counter, how long you're going to loop together inside. So this is your final answer. Remember again, your answer will be similar only for the red color. For the black one, normally you're going to get a different value. So you can see here when you try to remove your dumb register, you cannot see the printing. But when you have the dumb register, you're going to print each value. Just now for each loop. Loop 1, loop 2, loop 3, and lastly the final loop, which is loop 4. Okay. Finally the loop 4. I don't know whether I accidentally picked the mute, I guess. Okay, so here is the table on the basic addressing mode. You have immediate, direct, indirect, register, indirects, displacements, and step. So how are you going to use it in your code? What is the advantages and the disadvantages of the basic addressing? Alhamdulillah. So this is our last subtopic, which is instruction format. If you have any question previously, you can try to WhatsApp me. For previous day, if you WhatsApp me, I totally did not look into my phone. Every time after class, after class, I'm going to go back home and then I sleep. I rarely sleep. Normally, I will only sleep at night, like 2 or 3 a.m. in the morning. But now, after I got this flu, I cannot do anything. I cannot even think. Okay? What I want to do is I want to sleep. That is what I feel every time if I did not have any class. Okay? So, if you think that you have any important issues, you can direct call me, or you can just spam my WhatsApp. But for these few days, although you spam me, I will not look into my WhatsApp. I don't know what happened to my WhatsApp there. So here, and the last subtopic, which is instruction format, we have instruction length, allocation bits, and variable length instruction. So this is overview. As usual, I'm not going to read the slide. So let's see what is the most common instruction format we have. So remember, we have the 0 address, the minimum opcode that you can have, 1 address, 2 address, and the maximum 1 3 address. So how you going to apply to your code? So in terms of instruction length, this decision effect and its effect by memory size, memory organization, bus structure, procedure, processor complexity, and also processor speed. So this type of question normally will be coming out at the MCQ. Compared to the code last time, here all the example, it can be asked, a simple question can be asked in the MCQ, but like if we give you in terms of this full question, it will be coming out at the part B. So you need to have all the value we put beside the table, or might be in terms of storing data, a simple storing data as the example like this. We can also give in the MCQ, which is what is the value of 004005 maybe. So you need to know how to store the data also. Okay. Trade-off between powerful instruction and saving space. Okay, this one is under instruction length. Other issues, instruction length equal or multiple to memory transfer length. So this one is a question. What is other issues that coming up if you are using a instruction length problem? So in terms of allocations of bit, so in allocation bit, there is a sum of the factor that go into deciding the length of your instruction, especially in terms of the format. Therefore, an equal difficult issue is how to allocate the bits in the format, and the trade-off, it will be a complex in terms of allocations of your bits, especially when you play around with the addressing size. Sometimes it's not equal with the size that you mentioned, like maybe you have move words, and then you have the BL. So BL is 8 bits, here is 16 bit. So sometimes it is not similar, so it will become a problem. So the following interaction factor go to the determine the use of addressing bit. Number of your addressing mode. If indicate implicitly, certain opcode might always call for indexing. If it explicit, so there is two things. If explicit, one or more mode bits will be needed. That is under numbers of addressing mode. For numbers of opcodes, typically instruction has two operands. Use mode indicator for operand addressing. So all of this normally you need to remember, okay? It will come out with the multiple choice question. For register versus memory, You have a single user register, which is a accumulator. One operand address is implicit and consume no instruction bits. For multiple register, a few bits are need to specify the register. Number of register set. So you have one set of a general purpose register with 32 or more register in set. Let's say an example that you can have set of 8 register with the only 3 bits are needed to identify the register. So opcode will be implicitly determine which register set being referred. So this is number of register set. About address range, the range of address that can be referenced related to the number of bits. And lastly, address granularity, and address can reference a words or also a byte at your choice. You as a programmer, you can choose it. And byte addressing is the convenience for character manipulation. So this one is still under last one on the theory. In terms of variable length instruction, under variable length instruction, designer may choose instead to provide a variety of instruction format of the different length. So this static makes it easy to provide a large reporter of opcode with the different opcode length. So address can be more flexible with various combination of your register and memory reference plus your addressing mode. With this variable length instruction, there are many variations can be provided effectively and compactively. So that is the summary and the end of the module 6. So later on, we're going to do a recap. We're going to go one by one each slide to recap back what is important, how to tackle a problem, a question. So when I do that discussion time together, especially to spot a question, please give attention. Please memorize each important thing. Let's say I mentioned to you, okay, this diagram is very important. Might be this kind of question, blah blah blah, can come out. So please take it as important, because last time for your test 1, although I repeat several times, I mentioned, okay, at page number 7, this kind of question always come out. Might be it can be asked like this and this, but still lot of you cannot answer because I think you cannot focus, or might be you don't want to pay attention. I don't know. Of course, that class I cannot record because it's just a sport question and discussion together. So don't think that I'm going to record for you just because you don't want to pay attention at the class. So please make sure if I do that class, please attend and also pay attention, okay? So we finished module 4. Let's see what we have in module 5. Okay, personally, Personally, for me myself, I don't like this module because I think later on also it's more a lot of theory. You need to memorize many term, many definition in terms of the process and etc. Compared to the previous one, chapter 3, chapter 4, you play around a lot with program. Although I didn't like programming, but still you have something to play with. Compared to directly, I need to read all the slide. So I prefer chapter 3 and chapter 4, but you still need to go through all the chapter. So under module 5, it's a lot of theory. You're going to learn on processor organization. You're going to go deeper inside CPU. Last time we just know, as you remember, I always ask you, okay, CPU got 3, CPU got 3, which is ALU register and what else? CU, control unit. But although I repeat several times, you cannot answer the question. So I was like, okay. So you're going to go deeper. You have a control unit, ALU, and register. For module 5, you go all together. Later on, module 6, you're going to go deeper each one of these unit. Similar also, you can see control unit also going to be touched a bit in our module 5. So a register organization, instruction cycle, instruction pipeline, control unit appearance, and lastly microprogram control. Here also you're going to find out, I think there is a pyramid things last time I mentioned to you. If you find that things, you can see your test 1, 2, or 3 question come out only from that. I think pyramid one, right? Like layer. So you can imagine how to spot a question later on also, okay? Let's we move directly to our module 5. In our module 5, first of all, you're going to see what is the definition in terms of fetch instruction, interpret instruction, fetch data. So as usual, there is no other choice. You need to memorize the definition and what is the things under fetch instruction, which is read an instruction from memory. So again, always I mention to you as a simple as one single line here. I can just play around as a lecturer. I can give you a question, simple question for MCQ 1 mark. Fetch instruction is a read an instruction from input output, let's say. So by this statement, following statement, is it correct or not? So as simple as that, you can see, I can ask you a question. That's why if I am a student, I hate this subject because I need to memorize all, especially on theory. I don't like. Okay, so you don't have any choice. You need to memorize it. So under memory, you have register, cache, and memory. Interpreter instruction, the instruction is decoded to determine the what action is required. Fetch data, the executions of instruction may require data, reading data from memory or input-output module. Under process data, the execution of instruction may require performing some arithmetic and or logical operands of data. Write data, the result of execution may require writing data to memory or an input-output module. So here, let's see inside our CPU. You still remember that there is 3? Although most of you sometimes answer there is another one, which is all true in your test 1. I don't know why, although I always repeat 3, 3, 3 for CPU, still, yeah, okay. So you have ALU, register, and control unit in your CPU. And again, you need something. If let's say this is your heart, this is your liver, what else? I cannot think. Whatever is it. So you need to have a van to connect them together. Or might be from this, your body, you need to go to your mind, your brain. So you need to have a van to go connect them together. So this is also needed, which is a system bus that connect from one component to another. So you have a lot of type. Similar also in our vein. We have a lot of type of vein. Sometimes it will break. I don't know because I'm not medical person, but there is a lot of type of vein, right? So similar also in our system bus, we have control bus, which is just give you a connection in terms of controlling. Later on, you're going to see also what is the definition. Where is it? There is a table. What is the function of control bus? What is the data bus? What is address bus? So they have their own focus area. So in register, it's going to minimal internal memory. Mana penny? Consisting of a set of storage location, which is called a register. So if you still remember, you play a lot with register in your program. Your register last time, EAX, EBX, so all is register, and you're going to store, isn't it? That's why it is like a minimal internal memory. So it's going to use for storing. While for ALU, does the actual computations or processing of data. And lastly, our control unit control the movement of data and instruction in or out of the processor and control the operations of your ALU. Can we take a break 5 minutes? I think I already directly take more than 1 hour. So we need to take 5-minute break, and then after that we continue, okay?
Doctor,
Yeah. Yes.
can doctor put the module on the e-learning?
Yeah, I'm trying to save the.
Okay,
I
okay.
cannot move. No, I cannot move the slide. I cannot even exit. I don't know why. So I cannot see the Webex also. Aday, macam mana ni? There is no option at all. I need to open Task Manager, might be. Microsoft Point and Task. Okay, now can. Oh, my slide is already gone. Sure, Alhamdulillah. Sure. Okay, you can take a look in your e-learning. I already upload the module 5. I think I need to share also the class attendance because there is another 4 student not yet scanned. Okay, there is also QR code for those who still not yet scan the attendance today. Okay, class, let's start our class. We continue back. We have another more, like about 5 or 10 minutes. So let's start our class. Have you pinned me yet? Make sure you capture good side. My good side. Apa benda ni? Yang dia cakap sendiri. Imran, what are you doing in the chat? Mana Imrannya? Imran, are you here? Ay. It's okay. I don't want to waste our time. Since I also cannot talk too much. Let's we directly continue with our module 5. Where is my pen? Okay, the computer CPU which fetch, decode, and execute program instruction. So this is one of the function for your CPU. There are two principal part of CPU, alhamdulillah, which is data part and also control unit. So let's see in the internal structure of your CPU. Although you can see this is like a common view, you have 3 ALU register and control unit, but when you go deeper, you're going to see a lot of other things. So this is the internal structure of your CPU. You have the ALU also arithmetic, Boolean logic. This one is under your ALU. What else you have in your ALU? You have the status flag, shifter, complementer, and also arithmetic and Boolean logic. And then what else you have? You're going to have also register and also control unit, CU. So this is your register. So this is the whole CPU. This is whole CPU, and inside of this, after that, after this, when you go deeper and deeper, you see, oh, a lot of things they are doing inside just one single CPU. Last time we just know CPU, but actually a lot of the component inside. So when you want to communicate from ALU register and CU, you have we call as internal CPU bus, the bus system. Just now you see the system bus, right? The bus system. But we call it when we are inside, we call as internal. It's not going to outside. Might be you going to connect to like what are outside. Your input output might be in terms of your hardware of your memory. So that is outside. So when you are having the internal inside the CPU, we call as a internal CPU bus. So this is the connection to each other. When you want to connect from ALU, you want to communicate with register. When you want to communicate also and the control unit with others, so you have their own system bus. So you can communicate with each other. So here also they can communicate to each other. So this one we call as a control part. It will control when you want to communicate between ALU to register. It will control when you want to communicate between register and control unit. It will control when you want to communicate between control unit and also your ALU. So data path consists of ALU and storage unit register, which is storage unit register. This and this we call as data path that are interconnected by a data bus that is also connected to your main memory. Next we have just two, right? One is data path, another one is control unit. So another one is your control unit provide the signal to tell your data path, to tell your register and ALU, to tell the data path, memory and input-output device what to do according the instruction of the program. So you need to know the differentiation between control unit, ALU, and your register. Although it in a single similar CPU, but they have their own task. So control unit ask what to do, not ask, inform and provide to tell what to do to your ALU, which is data part, consists of ALU and also your register. Then the big differentiation between each other. So you also look that there is a internal system bus. Internal system bus, the register are interconnected and connected with your main memory through a common data bus. Each device on the bus is identified by a unique number that is set on the control line whenever the device is required to carry out a program. So separate connections are also provided between your accumulator and memory, and also ALU and the accumulator, and also memory. So there will be a separate connection. This permit data transfer between this device without use the main memory bus. You are using only the internal CPU bus only. While, as mentioned, you still need to have a system bus to connect to the outside CPU. So it called as external bus. A bus is a set of wire, like your vans, that simultaneously convey a signal bit along each line. So in terms of external bus, and the bus line here going to have categorized with data line, control line, and address line. Quite similar also with the control bus, data bus, address bus. But this one is the overall system bus. Now it is under external bus, you have the data, control, and address. But in terms of line, it's under a wired of external bus. So how it look like? So you can see here, if you still remember, we discussed this many times. This is the basic process for computer. You have input. After you have input, this one is keyboard, mouse, scanner, what else, all the input. You're going to input something instruction, open Microsoft Windows, open Paint, open Visual Studio. So all of this is input instruction, input device to your computer, to your processor, to your CPU. And sometimes it will be directly go to the output, but sometimes you need something inside. So there is a looping also in terms of storage your memory. So similar, when you see all of these need a connection to each other. So you can see components or typical bus. You have the CPU that process. You have memory, storage. This one is input or even the output device. And you need to have the connection to each other. And again, you're going to have different type of rings, different type of wire, different type of bus. Different wired, sometimes you have like blue color of wire, sometimes orange color. So all of that are having a different task. So same also, you can see address bus, data bus, control bus, they have their own task. You cannot just having one single connection to each other, one single connection to each other. So there is a lot of things later on, so it's mess. That's why your system bus can differentiate between address, data, and control. This is connection to CPU, you can see, and main memory, and your input output. So in terms of data line, control line, address line, later on we will continue. You can try to read what is the information. We will continue later in our next subtopic, registered organization. Please make sure to remember that you have only quite similar in terms of buses. You focus on address, data, and control. But when you are talk about inside, you have also similar data, control, and address. Only at the end of it's like different, which is line or might be a bus. But basically it is doing a similar task. When you combine all the data line, all the wired all together, we call as a data bus. Similar also the control line. When you have the control line internal or external, you can call as a control bus. Okay, so I guess only that for today. I hope next week I can feel like there is nothing happened to me. I want to like recover as soon as possible because I had this feeling. Okay, this recording I will upload to the YouTube as soon as possible. Similar also with our project. So when I share the project question, I hope that you can start discuss with your friend. In next class, I will explain what is the requirement and etc. for your project. Okay. So if you have any question, you can ask me. If I did not reply, sorry, because I really cannot see the phone for now. But if let's say it's very important, please try to call me, okay? Thank you, class, and sorry for the late. And yesterday I cannot make the